Okay, good morning, everyone. So, I'm going to continue with what we have learned in physics is under uh, physical quantity, okay, base quantity and SI units. In front of you, there will be on the screen. This is one of the question that um, I want you to do by yourself and find out what is the units for alpha and beta in terms of the base units. Okay, this one I want you to do by yourself and find out what is the unit of alpha and beta. Okay, okay, for today, we're going to learn about construction of empirical equation. Okay, as a student, you have to able to construct and develop a new equation based on experiment in physics. Okay, the only way is through the method we call as dimensional analysis, and the equation must be balanced both sides, which you can check using dimensional homogeneity method. Rename the dimension equation into standard unit equation, which represent using symbols that exist or proven by you or others. And finally, a new equation is born. Okay, so we want to see the factors of the variable, and by that we have also to maintain the equality between left hand side and right hand side. Okay, never mind. You see that this one. So for example, we have here, we want to know that speed of wave v by letter v on a string is depends on the mass of the string and the length of the string and the tension divided by symbol q. We can solve this by using the dimensional axis method. Okay. Now, how to get to solve this kind of question? First of all, is we have to write back what is the symbols that written on the question. Okay, so it says that the speed of the wave b or v, okay, is equals to mass divided by m, the length l, and the tension q. Okay, there are three things, the factor of the speed of the wave. Okay, so I assume that this is the speed of wave of a string, such as the speed of the wave that is when you have a piano, you have a guitar, any musical instrument. So this how fast is the wave of the string? Okay, so V equals to M, L, and Q. Okay, so we cannot just create any physics equation with this kind of method because it should be balanced left and right. Okay, so we have put here x and x for the power of m, y for power of l, and x for the power of x, y, z. Oh, sorry, this is z. Okay, z for the power of the q. So q here is the tension. Okay, so remind yourself, the dimension of all the physics quantity v is a speed. So speed is v, velocity. So it is L t negative 1. Okay, dimension, bracket of dimension. Mass is also mass, capital M. And the L is the length. So L, capital L. And Q is the tension. Okay, tension is a force. Okay, in Newton. Unit for tension is in Newton. So force F equals to ma, and m in a dimension is mlt negative 2. Okay, so what we have here is mlt negative 2, power negative 2. And remind yourself, we want to continue with the power or indices. So x, this is y, and this is z. Okay, and after that, we going to expand those indices of power. So I write here is m mx mx m only have mx over here, and L has y, and this one when you multiply, so you have m. I'm going to remove the bracket. Okay. So m z L z t negative 2z. Okay, so I expanding. Okay, multiplying the in this power, and then you have, if you regroup again with the what I call the dimension is m x over here and over here, so x plus z, and then you have a L over 1 and over 2 here, times with L y plus z, and times, then you have t negative 2z. Okay, so you can see that I'm regrouping every dimension, okay, of mass, length, and time. Okay, and remind yourself, on this is on the right hand side, on left hand side will be lt power of negative 1. Okay, so you see that in the screen you have m mass, you have a length, and then you have time, but this one you have time L, and actually one more thing, that is m is power of 0. Okay, it is equals to 1. Power of 0 is equals to 1. Okay, now we're going to do operation on the indices. So for m, okay, m it is 0 equals to x plus z. Okay, so this is number 1. For L, okay, you have this is 1, okay, equals to 1 equals to y plus z. Okay, this is equation number 2. And for t, you have negative 1 is equals to negative 2z. This is number 3. Okay, so you're going to, I think it's easier if you do number t first. That is negative 1 equals to negative 2z. So negative 1 over negative 2 equals to z. So z equals to 1 over 2. Okay, and then we can substitute z equals to 1 over 2 in equation number 2. So 1 equals to y plus z. So 1 equals to y plus 1 over 2. So y is equals to 1 minus 1 over 2. You have 1 over 2 also. Okay, and you have a z, you have y, now you have 1 to get x. So 0 equals to x plus z equals to x plus z is 1 over 2. There you have x equals to negative 1 over 2. Okay, so now we have everything here, like x equals to 1 negative. Okay, so you have everything here. So every power that you have calculated, the working that you have calculated over here, that is x, this is z, and y, you have to put back into the first equation. So what you have here is v equals to m, x is negative 1 over 2, Okay, and L you have 1 over 2, and Q you have Z is 1 over 2. Okay, so you have to operate the indices. That is, this is M, uh, 1 over square root of M, okay, times with L is half, half is square root, okay, of L, and Q is square root of Q. So what you have here is square root of everything, L Q divided by M. Okay, so this is the end of the result. Okay, so V equals to LQ divided by M. Okay, so left side and the right side are equal. So this is how the physician create their own uh, formula by seeing what is a factor or variable that affect the equation title. Okay. Mm, okay. I hope you understood this one, this example. Okay, going to the next example over here. Okay, the next example is we have a frequency f of the note produced by the stretched string depends on this length L, the tension T of the string, and the mass per unit length m of the string. Use the method of dimension to derive the equation of f. Okay, so the first thing we have f over here as the equation title, f, and depends on the length L and the tension T, and the mass per unit length is m. Okay, so I put over here f frequency depends on the length L and the tension T, and the mass per unit length m divided by small m. Okay, so as usual, the first step is we rename this is x, y, and z. Okay, now we have to remember we have to turn everything into its dimension. So frequency is hertz or in per second. You know that frequency is 1 over t and is second over second, so it is a t uh, power of negative 1. So this is t power of negative 1, okay, equals to L is a length, so I put the big capital L over here. T is a tension, as we remember, is a force, so force is M L T negative 2, and M is a mass per unit length, so it's a mass per unit length, so it's a mass per unit length that you have here. Okay, so we have to put back the x, y, and z into the equation. Okay, or you can put this one as well. I'm going to do again. Okay, it's easier. Is m l negative 1 and it's powered by z. Okay, I can see it. Of course, the next step is to expand. So L x m y L y t negative 2y m z L negative z. Okay. Uh, so next we have to regroup all those dimension into one. So we have L here, you have L here, you have L here. So you have L x minus, oh sorry, there is y here. So you have x plus y minus z. Okay, and then you are going to regroup the m 1, 2, that is my plus z. Okay, and also you have to regroup the t, and the t here is 1 only. Yeah, this 1 only. So t negative 2y. Okay, for the left hand side you have L0, t negative 1, m 0. Okay, so we're going to play with the indices. So for L, 0 equals to x plus y minus z. For t, you have negative 1 equals to negative 2y. For m, you have 0 equals to y plus z. Okay. So we start with the number. This is equation number 1. This is equation number 2. This is equation number 3. We start with the equation number 2. It's easiest. So negative 1 equals to negative 2y. Y is 1 over 2. And then you have, we're going to use equation number 3. So 0 equals to y plus z. So 1 over 2 plus z. Okay, 0. And z equals to negative 1 over 2. Okay, so now we want to find the x equals, using the equation number 1, x plus y minus z. X is the one we want to find. Y is 1 over 2 minus z is 1 over 2. So you have x plus 1 over 2 plus 1 over 2. This is 1. So x equals to negative 1. Right. Okay. Plus plus. Oh, yeah, correct. Okay. I'm going to finish the whole thing. Now you find out there is f equals to L, the x is negative 1, t is y is 1 over 2, and m is z is negative 1 over 2. So what we have here, negative 1 is 1 over L in bracket, and t is square root of t, and m is 1 over 2, 1 over square root of m. If you multiply, you have square root of t divided by L square root of m. So this is the answer F. Okay. So I hope by using these two exercise and these two equation, I hope you understood the steps to find out to do the empirical equation. Okay, it's not hard actually, but you have to remember what is a step to find out the equation. Okay, so I'm going to stop at empirical equation today. So I want you to do this one. Okay, it says that from observation made by a student, he inferred that the possible factors that determine the speed, okay, v of a transverse wave in the stretched string are the mass per unit length, okay, of the hint is m over l of the string, and the tension T in the string. Use dimensionalities to construct an equation for V. Next one, the next exercise is a drag. The drag F. Okay, the drag is a force. Okay, unit in Newton. Experienced by vehicle depends on its velocity V, density of the air rho. Okay, and the cross-sectional area A of the vehicle. Okay, derive an expression for F. Okay, So I want you to do these three empirical equation, okay? And I will also put up homework, okay, in the WhatsApp, so you can do and try yourself. You can find either you can do it or not. If you have difficulties, you can ask in the WhatsApp group. Okay, I'm going to stop here. Bye bye.